Alright guys, so today we're going to be doing adding fractions with unlike denominators. Alright, so remember that whatever I put on the board, you're going to put on your paper. What I do, you do. Alright, we're going to start today with 1/2 plus 1/4. Okay? 1/2 plus 1/4 on your paper. Alright, now, before we start this, let me ask you a question. What is 1 adult plus 3 adults? 1 adult plus 3 adults. Miguel?
4 adults.
4 adults, alright. What is 2 children plus 2 children? Brandy? 4 children. Okay. What is 2 adults plus 3 children? Haley?
5 people.
Okay, why did you change the word to people?
Because the children aren't as old as the adults and the adults aren't the same age as the children.
Okay, so we have 2 different categories. You can't add adults and children without changing the name of it, right? So think of it like this. We can't add 1/2 plus 1/4 without changing our group or our name. Put your hands down for a second. So what we're going to do first is we're going to make equivalent fractions. This is going back to what we did in lesson 1. So I want everybody to draw a box. And we're going to label it 1/2. And then we're going to draw another box. And we're going to label it for 1/4. How can I label my half box? Hayden.
You can make a horizontal line.
Okay, so we want to make a horizontal line.
I did vertical.
We can do a horizontal, that's okay. So let's change our horizontal line. And then what are we going to do with our box after we draw that line? Chrislyn?
We shade one.
We shade one section of it. So I'm going to take my crayon and I'm going to shade one section to show half. Alright, now we're going to do the same thing with our 4th box. Okay, but I want to do it in a different direction. So how can I show and model this box? Brooklyn?
You do it horizontally.
Okay, well, we did horizontally. Remember, horizontal is like a horizon, so it's going across. So we're going to do vertical, meaning standing up. And how many sections does this box need to be divided into?
3.
How many?
3.
It needs 3 vertical lines, which would give it 4 vertical sections. So we're going to divide it in half one time, and then divide that half in half, and that half in half. Alright, now using a different color, I want to shade in for 1/4. So Kiara, how can I do that?
You can shade in one vertical box.
One vertical section. Alright, now this is a little different from what we did in lesson 1. To show and to change our denominators here, whatever we did to this half box, we're going to do the same exact thing to this box over here. So, aside from the shading, what did I do to this half box?
You made a horizontal.
Okay, go ahead, Peyton. What?
You made a horizontal line and shade.
I said aside from the shading.
Oh, you made a horizontal line.
Alright, so all we can do is we can make a horizontal line. So now, how many rows do I have in my 1/4 box? Baha.
Wait.
How many rows?
Oh, yeah. 2.
2. Remember, this is going back to it. So 1 times 2 is what?
2.
And 4 times 2 is what?
8.
So 1/4 is equal to 2/8. And now we're going to do the same thing to our half box that we did to our 1/4 box to start off with. So what did I do to my 1/4 box? Brandy?
You made a vertical line.
I made vertical lines. How many vertical lines did I do? Okay, 4 sections, but 3 vertical lines. So 1, 2, 3. So I have half, and then I have, how many sections did I add to it? How many vertical sections do I have? 4. And so 1 times 4 is?
4.
And 2 times 4 is?
8.
So our new fractions are 4/8 plus 2/8. Do we have the same denominators now?
Yes.
So now all we have to do is add our numerators. What's 4 plus 2?
6.
And our denominator will stay the same. Michael?
God showed us a different way, like.
We're not going back to 4th grade. We're in 5th grade. Okay? All right, any questions on what I just did for this particular problem? I'm not quite done yet, but any questions right now? Jesslyn? Keep in mind, I'm not quite done yet. Anything on what I have just done?
How did you have to multiply half with 1/4 times 2 and 2, and you have to do 1/2 times.
4 over 4. Okay, so what was the difference? What did I do differently to this box?
You just shaded vertical.
No. I started off in this box with vertical lines. Right? That's how I started off. And then I came in and I added this horizontal line, which gave me 2 rows. So I multiplied by 2. Do you follow that? Yeah? Okay. So on this box, I started off with a horizontal line, and I came in and I added 4, 1, 2, 3, 4 vertical sections. Does that answer your question? Okay. All right. Cameron. Huh? Yes, I am still recording. All right, PR.
Does it make a difference if you, like, nation and circle, second box, you did, like, you multiply it, like, to the, second, first box, you did, like, 4, but does it make any difference if you start, like, if you multiply it by vertical or horizontal rows and columns?
What you are multiplying by is what you changed in that box. So like I was telling Jesselyn, on this 1/4 box, my change was that I made 2 rows. So I multiplied by 2. On this 1/2 box, I added in 4 columns, so I multiplied by 4. We're going to do some more practice with it, and once we start doing some more, it should start clicking in. All right, but let's look at something else. Remember I said we're not quite done with it. Do both of these boxes have the same number of sections in them?
Yes.
Yes. They both have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? So the pieces are the same size, correct? All right. We're going to look at taking these 2 pieces and moving them over here. So if I add in this piece and I add in this piece, how many pieces do I have shaded inside this one box here? I have 6. 1, 2, 3, 4, 5, 6. Out of how many? 8. All right. This box can also be simplified. All right. How could I divide up this box to show a simplified answer? Hayden?
You could make dotted lines right down the middle horizontally.
Or vertically, and horizontally. How many sections do I see shaded in right now?
3.
So I see 3 sections out of how many sections?
4.
So then 6/8 is also equal to 3/4. I do. What did I divide 6 and 8 by to get 3/4? 6 divided by 2 and 8 divided by 2. All right, does everybody have it written down?
Yes, ma'am.
Oh. So we got caught up in paying attention, which is fine. And we need to write it down now. Max, you got it written down? Make sure you have every component written down. How I simplified it. How we showed our model with our adding. How we solved our problem using just straight computation. You can use colored pencils, I'm fine with that. Alright, let's take a look at problem 2. Alright, for problem 2 we have 1/3 plus 1/2. Alright, we're going to do it the same way. Everybody sit up. Alright, so we're going to model 1/3 plus 1/2. Alright, how can I model 1/3? I love that Brandy and Caden and Chrislyn and Kiara all raise their hands. How can I model 1/3? Gabe?
Draw 2 vertical lines.
2 vertical lines. Vertical meaning straight up and down, okay?
And chain.
And shade in one of them, one section. Okay, how can I model 1/2? Jesselyn? I can't hear you, babe. What? Alright, I did vertical over here. 1 horizontal line. And then what? Shade in one of them. I'm going to use a different color. Okay. Now we need to make the equivalent fractions. So remember that when we divide up these boxes, we're multiplying by whatever change we make to the boxes. Okay, so here in the 1/3 box, we started off with vertical lines. What did I do to this 1/2 box? Whatever I did to the 1/2, I need to do to the 1/3. So what did I do to the 1/2? Brandy.
You added a horizontal
Okay, so I did a horizontal line, which gives me now how many rows?
6, 9,
Okay, think about it. A row goes across.
2,
So I have 2 rows. 1, 2, which means I multiply by 2. So 1 times 2 is what?
2,
And 3 times 2?
6.
6. Okay, so our 1/3 is equal to 2/6. Now we need to do our half box. Brooklyn, what did I do differently, or what did I do to my 1/3 box to start off with? Because I need to do that same thing to this half. No,
Vertical line.
2 vertical lines. So 1, 2. This gives me how many columns?
2.
No.
3.
1, 2, 3 columns. That's what I'm going to multiply by. Justin, pay attention. 1 times 3 is what?
3.
2 times 3 is what?
6.
So we're adding 2 6 plus 3 6. What, Kate? Because you started off with 1/2, so you're multiplying by what you do differently to the box. Because you've already modeled the rows. You have 1 row out of 2 rows shaded in. You're multiplying by what you've done differently. Okay, Chrislyn.
I don't understand that. How come there's 2 rows and you can count the 6 inside it, so we count the 6 inside 1/2?
Okay, again, that's just what Kaden was saying. We've already started off, this is rows. So this 1/2 here is talking about the rows. We already have 1 row out of 2 rows, right here. Do you see that? All right, so this is the columns. We're multiplying by the columns. Over here, your 1/3 was the columns, and then you're multiplying by the rows. Y'all see that? So to find your equivalent fraction, you're always going to multiply either you're going to multiply your columns by your rows. Okay? So now that we have equivalent fractions, or we have common denominators, 2 6 plus 3 6 is what?
5, 6.
5 6. Uh-huh.
I recognize that over there the 3 2 was the bottom, but now it's on the
That's completely coincidental. Do not ever base doing your problems like that. Nothing. It's not, no. Completely coincidental. I don't even want to draw attention to it. Okay. Is there a number that I can divide both 5 and 6 by? It's the same number, and I get an even answer. Can I divide 5 and 6 by the same number and get an even answer? Mm-mm. What?
Divide?
Mm-hmm.
You
No.
can't do it because they're both not. They're both. The top isn't even.
Okay. So the only things that you could divide by 5 to get an even answer are 1 and 5. Well, 1, if you divide by 1, you're going to get the same thing. And 5 cannot go into 6 without getting the remainder. So then this is your simplified answer. So it's already simplified. Okay, any questions on that one? Got a lot of people not paying attention right now. Cameron. I'm sorry, say that again.
When we started out with this, nothing at all. Because we started out with 1/3 was 1/2. Now we're 2/6 plus 3/6 equals 5/6.
It's not nothing. That 1/3 is equivalent to 2/6. This is just like me saying 3 adults plus 2 kids. You can't do that. All right, so you have to find an equivalent name for them, a name that means something. Well, in this case, that name is 6. Okay, so we made equivalent fractions, and then we had to add them. Okay. All right, let's try one more, and then you guys are going to get your problem set. All right, so now we have 2/3 plus 1/4. 2/3 plus 1/4. Again, drawing our 2 boxes, we're going to model for 2/3 plus 1/4. All right, Tiana, what can I do for 2/3?
We can add two lines to make it a 3-column and shade in one. I like shade in 2.
Shade in 2. How you want me to do vertical lines or horizontal lines?
You can do vertical.
Okay, so 2 vertical lines, and she said shade in 2. So we have 1 and 2. Okay, there's my 2/3. All right, Brandy, what can I do for 1/4?
You can draw
Okay, so I want to stick with just horizontal because I did vertical here. So I need to do horizontal lines. How many horizontal lines or how many horizontal sections do I need to have? 4. So that means I'm going to draw 3 horizontal lines to give me 1, 2, 3, 4 sections. And she already knew to shade in one of them. All right, Kiara, what can I do to this 2/3 box to do that equivalent fraction? Very good. So I do whatever I've done to the 1/4. So I'm going to draw 3 horizontal lines, which gives me how many rows?
4. Yes.
So I'm going to multiply by 4. 2 times 4 is?
6.
What?
8.
2 times 4 is what?
8.
Okay, there we go. And 3 times 4 is?
12.
So then 2/3 is equivalent to 8/12. And now what am I going to do to my 1/4 box? 1/4 box. Danya, 2 vertical lines. 1, 2, which means that I'm multiplying by what? 3, because we have 1, 2, 3 columns. So 3 times 1 is?
3.
And 4 times 3 is?
12.
And so our 1/4 is equivalent to 3/12. Since our denominators are the same now, we can just add our numerators. 8 plus 3 is what? 11, and our denominator stays the same. Is there a number that can go into both 11 and 12 evenly?
Yes, 4.
All right, Caden, 4 can go into 11 how many times?
Oh, wait, I was thinking
11 is an odd number, 12 is an even number. It doesn't always happen that you couldn't do that, But in this case, there is no number that can go into both 11 and 12 evenly. 2 can go into 11 5 times, but you have a remainder. So when we say evenly, it means no remainder. Kiara.
Do you know a fraction can be simplified? How do you know which number to choose?
If whatever number could go into it evenly. So if this were a case, and just to kind of get off track for just a second, if we had 10 over 12, what number can go into both 10 and 12 evenly? Okay, so we could divide both of them by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. You can literally choose any number. If I had 12 over 16. All right, 4 can go into 12.
3.
And 4 can go into 16 4 times. Now I'm just making up fractions right now just to show you that you can choose any number that goes into both the numerator and the denominator evenly. No remainder. All right? No remainder. Michael?
It doesn't have to. When you divide
When I'm simplifying,
does the numbers have to be the same way you divide into a fraction?
these, yes, has to be the same number. Because that's how you do equivalence. If you've noticed, when we're multiplying, these are the same. This is the same. 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 It's not equivalent unless you are multiplying or dividing by the same number. Kaden.
How would, if we have 21 and 28, 21 is an odd number though.
Yeah?
And you could divide both of them into 7.
Yep. That's why I was saying it doesn't always matter that one is odd and one is even. You have to look at what they're divisible by. So 21 is divided by 7 is 3, and 28 divided by 7 is 4. You could also look at 6/9. 6 is even, 9 is odd, but they're both divisible by 3. Rose? No. Any questions about what I have done for these 3 problems? Cameron, what's your answer for this one? 11/12. You don't have to label these because
I'm just saying, what is it?
a fraction.
No, what is our answer? Like, what is it?
11 shaded boxes out of 12.
What is our answer? You have to label it.
11 boxes out of 12. The only way that you would have to label a problem would be if it's like a word problem and it's talking about something specific.
I'm not saying that you have to label it. I'm just he's asking.
I think what he's saying is
He's asking what problem would be your answer.
I think what he's
What would
saying
be your
is
answer?
like there was 12 apples and there was 11 eaten.
I don't think that's what he's saying because he's looking at you like you're insane.
No, I think he's kind of asking what would be the answer if, like, the question was asking something else and you did all that, what would be your answer?
I still don't understand the question. So when we're doing our problem set, if you can give me a better version of that question, then I'll try to answer it that way. Okay? All right. So we're going to go ahead and do our problem.